All right, this is Don't Write Macros on the screen. Hopefully you're in the right room. There's a little switcheroo. This is Don't Write Macros. So welcome, my name is Jesse Anderson, and clearly today we're going to be talking about macros. So first off, why are macros a thing? Like, why macros? What's the point? What do they get you? Why are they a thing? So to me, I think of macros as kind of the answer to the question, how do you write good code that's also like beautiful and easy to read? And macros give you that with a few different things. They can hide your boilerplate code. They can also, you can make like a code pattern that'll just repeat it to generate code for you. And they're also really good for domain-specific languages like Phoenix, Ecto, XUnit, things like that. And also, when you hear the phrase like most of Elixir is written in Elixir, that's using the power of macros. Without macros, that wouldn't really be possible. But because of it, most of Elixir truly is written in Elixir. And there's even things that you might take for granted as kind of like your basic building blocks of Elixir, like def and def module. Those are macros, and everything is built with Elixir behind it until you get to this really small part where it's no longer Elixir, and we're gonna talk about that. So if macros are so cool, why not macros? Like, why is the talk called Don't Write Macros? Whenever you look into macros and you read like tutorials or books, you'll often find, and I think Stuart Holloway was the first to say this, the first rule of Macro Club is don't write macros. And if you've seen like Chris McCord's talk, he has his two rules, and his first rule is don't write macros. His second rule is write them gratuitously, and we're just gonna ignore that for this talk. So don't write macros. And there's a reason that that's like the warning up front when you're learning about macros. And that's because macros are really powerful and they're really fun. Like, you can do a lot of kind of crazy stuff with macros, and the power gets kind of addicting. You're like, yeah, I can do this and I can do that, and I feel so clever writing this code. This is like the best way to possibly do this. But the problem with that is you lose the idea of the code being beautiful and easy to read. Sandi Metz says, code is read many more times than it is written. So, which means that the ultimate cost of code is in its reading. And this is the problem that people often early on when they're writing macros run into. It's really fun to write, and to you it feels great, but future you, or some other person that comes in, suddenly it's like, how does this macro work? I don't even remember what was behind this. So it's really important, even if you're not using macros, to understand how they work, because like I said, most of Elixir is kind of built on top of the macro framework. So we're gonna start off with something a little bit basic. Instead of defining macros right now, we're gonna just look at a basic if statement. And we're gonna kind of break down some basic code style just to make sure kind of everyone is on the same page here. So we're gonna take this basic statement, if 1 plus 2 is equal to 3, then do this, else do that. Really simple, but if you think in terms like if you're like beginner learning Elixir and you got like your module.function and then your arguments in parentheses, what is this compared to that? So we're gonna go ahead and just break it down to make it look a little bit more like kind of our traditional module.function arguments in parentheses. So first off, we can throw some parentheses on here, and then we see, okay, if is our function, and then we've got our arguments in here. But we have a couple of commas, which is a little bit confusing if you don't know. There's some syntactic sugar when you do keyword lists. You don't actually need the brackets on the side. So we're actually going to go ahead and add those, because it looks at a glance like this is 3 arguments here. So we're going to go ahead and add those brackets. So there we got our brackets. And now we can kind of clearly see there's 2 arguments. We have our first argument, the 1 plus 2 is equal to 3. And then we have our second argument, which is a keyword list of do this and else that. All right, so we're looking pretty good. There's a little bit more we can do here. We have that 1 plus 2 is equal to 3, which on the surface seems pretty clear. It's like, well, that's kind of basic arithmetic. You're adding on the left and then seeing if it's equal to what's on the right. But let's again think about that in terms of your module.function with arguments. So we're going to break this down, and what you first have to do with this is break down, well, what is 1 plus 2? Before we can see if it's equal to 3, we need to add 1 and 2. So we'll take that, throw it in parentheses, and what we have here is actually a function with 2 arguments. It's called an infix operator, which is a different way of doing certain functions where you have the function name in the middle, and then you have a left value, which is your first argument, and then a right value, which is your second argument. So we're going to actually take this plus, which is the function name, and move it to kind of the traditional syntax where you have it in the front, and then you have your arguments listed inside. So that's kind of looking more, again, like a traditional function definition, where you have function, and then you have 2 arguments inside. It's a little bit weird because a symbol as a function name seems a little bit strange, but that's kind of, most infix operators are that way, where there's some sort of symbol that sits in the middle of the 2. So we're looking good. We now have the function on the left ready to evaluate with the one on the right. You might be ahead of me here. Here with the double equals, we have another infix operator. So it's a function with 2 arguments. The first argument is the plus 1 and 2, and the second argument is the 3. So we'll move that to the front too, and now we have our double equals, plus 1 and 2, and the 3. And this is looking good. Yeah, we got our 2 arguments, the 1 and 2, and the 3. But we're missing one thing. When you aren't using the double equals as an infix operator, you need the module name. It doesn't work without the module name. So we're going to go ahead and add that in there. So now we've got our kernel dot double equals. And clearly we need to do the same thing with the plus. So now we have kernel dot plus. And now we have this really simple, easy to read function situation here. And we're going to go ahead and plug that back into our original if statement. So now we've got the if. We'll plug in that kernel in place of 1 plus 2 is equal to 3. And now you have this beautiful, easy to read line of code, just your pure, simple module function name with arguments. And it's really clean, piece of cake. Oh, we forgot something. If needs a module name too. So that's actually macro. So we're going to put macro module name on there. And now we have it. Now we're done. We've got it. And this is looking great. Isn't that so much easier to read than if 1 plus 2 is equal to 3, do this, else that? No, it's not. Thankfully, we do not have to write in that first line syntax. We can use this nice thing on the bottom. And some of that is using macros, and some of it is just using some syntactic sugar. But that is a much better way to write code and to read code. That's kind of the really important point, is it's easy to write and it's easy to read. So that is a great use of that. Excuse me. The reason we don't have to write in that really complicated way is the compiler kind of takes care of that for us. The compiler is going to take our code and deal with whatever syntax we give it and break it down to what it needs to be. Somebody named Mihao, he's really popular in the Elixir community Slack group. I highly recommend joining that if you're not a part of that. But a couple of weeks ago, he kind of broke down the steps the Elixir compiler takes. So we're going to go ahead and take a look at those. And to be fair to him, he said it's something along the lines of, so there might be 1 or 2 things off here. But we start off, the Elixir compiler reads your file, and then tokenize, parse, where it builds the AST, which stands for Abstract Syntax Tree. And then we expand macros, apply rewrite rules, and then we lower the Elixir AST to the Erlang AST, in which the Erlang compiler takes over. And then we compile the Erlang AST to the core AST. Oh, then we got to do core optimizations and some true inlining. Compile pattern matching, which now we have the kernel Erlang, and we run the kernel optimizations, obviously. Generate the assembly, optimize that assembly, generate some bytecode, and then finally we write the .beam file. Piece of cake. So this is my version. It's not as complete as Mihao's, but I have step 1, you take your code. Step 2, build the abstract syntax tree. Then we have step 3, and then step 4, the beam. We're done. Piece of cake. Much easier to follow. So we've mentioned it a couple times, the abstract syntax tree. If you're not familiar with this, it's common. I don't know if most languages have some sort of abstract syntax tree, except for like, well, some of them, they just are the default language is abstract syntax tree. But really what this is kind of what we were doing before with our if statement, where we break it down into kind of like the pure function version of it. What we did wasn't the actual AST, but it's kind of close to that. And we're going to take a look at this. But one thing that's really cool with Elixir is the abstract syntax tree is written in Elixir terms. Most languages, that happens in the compiler, so you don't really have to know or care about it. With Elixir, since it's written in Elixir terms, you can actually view it and edit it and do lots of really cool, powerful stuff. So we're going to take a look at that real quick. So the language of the AST is, first you have quote literals, and these are the kind of things that when you write it in your code and then the compiler converts it to the AST, it looks exactly the same. So this is things like an atom, integers, floats, strings, lists, and two-element tuples. So these, when it's converted to AST, it looks exactly the same. So these are kind of like your basic building blocks inside of the AST. Everything else is represented by three-element tuples. And there's kind of two main types of that. One is a variable. So most variables are going to look like this, where you have the variable name as foo, and then you have the second argument is your metadata, which there usually isn't for your kind of basic variable. And then the third one is the context, which is often just Elixir. And then the second kind of three-element tuple, and this is kind of what we're going to focus on finding out about right now. This is called a call, and that has like your function is the first element of that tuple. The second element is your context and metadata, and then the third one is the arguments for the function. That's the first element. So we're going to focus on that. We're going to see a few examples of this right now. So we'll start off with just real basic 1 plus 2, and we broke that part down before as kernel.plus, and then the two arguments 1 and 2, because it's an infix operator. The actual AST version of this looks like this. So you can kind of see the bits and pieces in there. We've got the plus, the function right there is at the front. And then the third element is the arguments for that function. So there's our 1 and 2 inside of a list. And then inside we have our metadata. And most of the time when you're dealing with macros, you can ignore this. And most tutorials will kind of tell you that too. This is sort of the extra data that Elixir needs, but you usually don't need this when you're kind of manipulating this data. But as you can kind of see here, you can kind of guess and kind of figure it out, like, okay, the context is Elixir. And oh, there's our module name, kernel, being imported. So that's sort of like the basic AST example right there. We're going to talk about a few handy little macros now, a few handy macros and functions. The first one is quote, and quote takes any code that you have and converts it into that AST format. Since, like I said before, the AST format is Elixir data, so you can just convert it with quote any code that you have. Unquote does not do the opposite of that, despite the name. Unquote does lets you inject code into that quoted expression. Quoted expressions is another term for the AST format. So you take code and you run it through quote, and then it's called the AST or a quoted expression. So unquote lets you inject code into that. Macro.toString is a function that's going to let you convert a quoted expression back into a readable Elixir format. It's in a string, so it's not like code you can run, but you can visually see what the code may have looked like before. And then the third one we're going to talk about is def macro, which maybe you can guess is for defining a macro. So first we're going to look at quote. We're going to translate some code to that quoted expression AST format. So we'll jump over to IEX, and we're going to do quote do 1 plus 2. And quote works just like any do blocks. You could say quote do and then have 100 lines of code and then an and at the end. And that's going to give you probably like 800 lines of code when it's quoted, because that's kind of how it works. So we're going to check this out, and we see like, okay, that's what we saw before. We have our plus function with the context import in there, and there are arguments at the end, the 1 and the 2. And then we'll do another quote. We'll do quote do atom, and surprise, it's the atom. We'll quote do a list, and we get the list. So that's sort of your basic how quote works. Unquote, like I said, it kind of like injects that code. It's like it kind of works like how strings do, where you're kind of injecting, you want the value of a variable to show up in the string. And it's kind of easier to just see in action, so we'll take a look. And you can only use unquote inside of a quote do block. That's where it's used. So we do our quote do with the 1 plus 2 and see what it is, like we just saw. And now we're going to define a variable called foo. We're going to define it to 2. And then we're going to take quote do 1 plus foo. And instead of getting the 2, it's going to default to giving it the variable. And there we see our 3-element tuple of the variable with foo and the context of Elixir. But that's not what we want here. We want it to actually take the 2. So we can do the same thing, but we wrap foo in an unquote call. And now it's going to grab the value of foo and place it in there. And then you get the same as you had at the top, the function with the 2 as part of one of the arguments. And again, this is kind of just like a string, so I'll just show that real quick. Foo equals 2. And you say the value is foo. This is going to work, right? No, clearly it doesn't. It just prints out the value is foo. But if you wrap it in the little curly brackets, then it's going to kind of take the value and place it in there. And then you get, the value is 2, which is what you want. So that's the second of our 4 little useful functions. Our third one is macro.toString. So this is how you kind of, when you have an AST and it looks crazy and you want to see, like, what does this actually look like in code? So we're going to do that real quick. We'll define a math problem as the quoted 1 plus 2. So it's going to take our 1 plus 2, convert it to the quoted expression AST format, and then define it to, assign it to math problem. So now we have math problem is that quoted expression there. And now we're going to say macro to string that math problem. And boom, there we go. We get a nice string back that tells us this was 1 plus 2, which is really nice. And now we're going to do one a little bit more complicated. So we're going to take, say, foo equals quote do, and then that original one, if 1 plus 2 is equal to 3, do this, else that. And this gives us kind of this big old mess of code because there's a lot of kind of nested stuff going on in there. But to break it down just a little bit, you see 3 of these have the same context as Elixir, import, kernel. So we're just going to hide that to make it a little easier to look at. And now you can see inside, okay, well, there's the plus function with the 1 and 2, so 1 plus 2. And then that's the first argument of the double equals function. So now we see, okay, so 1 plus 2, if it's equal to 3. And then you have the if kind of wrapping the whole thing with the do else block at the end. So that's that. It looks really intimidating, but it's really not that much going on there. It's just kind of messy to look at when you're not used to it. So anyway, so we're going to take that and macro to string that. And you see there, it gives us this kind of, and you see some like new lines in there like, oh, well, let's pass it to io.puts so it actually prints the new lines. So we'll go back up, pipe it to io.puts, and there we go. There's our if statement. And interestingly, it changes it to a multi-line statement because as it's turned into a quoted expression, the code formatting that you use to write it does not matter anymore. It doesn't care if you used 4 spaces or 2. You should use 2 for indentation. It doesn't care about it doesn't care if you use parentheses. It doesn't care if you did it on the single line or multiple lines. It just kind of breaks it down to what is the core set of functions happening with this code. And so then when it converts it back, since it doesn't have that data, it just kind of uses its own way. So, which is great. Yeah, so there we go. We started with the 1 line up there, and now it's multiple lines. So we're going to take a look at a few more AST examples to kind of break this down. You may have noticed before when we went through the quoted literals that a 3-element tuple wasn't listed as one of the literals. So what does like a regular old 3-element tuple look like? And you get this. So it turns into the 3-element tuple call, where the first element in it is this kind of crazy looking function, and that's how you define a tuple, is with the 2 brackets is the name of the function that defines a tuple, and it just takes a list of the arguments and converts that to the tuple. And kind of have the same thing happen here with map. So we have a map here, and it does the same thing. We have kind of the wrapping bracket is the name of the function, and then we have the keyword list is in there as part of the list. Now we're going to take another quick simple example. So io.puts hello. What does this look like? And we get this mess. What is going on there? There's a lot of code going on here. Let's break this down. First, we'll move it on 3 lines so we can see like, oh, Okay, it's another 3-element tuple, which is good. That's what you would expect. The third line is our argument, the string hello. The second one is actually an empty keyword or empty list, and that's where normally the metadata would go. But in here, there doesn't seem to be any metadata. And then we have this crazy line, which is a little strange because you're expecting an atom that's the function name here, but instead we have like some nested tuples going on. So we're going to go ahead and take a look at that. But you do see at the end of it, you see our IO and puts are in there somewhere, but they're not even like next to each other. Like what is going on? Let's check this out. So we're going to break that tuple down again so we can see the 3 lines, the 3 different elements. The first one we have a dot, which is kind of weird if you've never seen this before. Like why is there a function that's just a period? What is that function doing? So I went on a little investigation to figure this out because this was new to me when I ran into this the first time. Like, what in the world is this? And my little journey led me to this cool thing called kernel.specialforms. Anyone here familiar with special forms? Raise your hands. Yeah. Okay. So maybe like a third. So this is kind of like where the rubber meets the road. This is where things get crazy. These are basically the basic building blocks of Elixir are inside of this module. You've got you can see some of the crazy there's a map listed over there in the left hand side, and some other weird symbols, really kind of crazy definitions happening in here. And if you scroll down a little bit, you can see there's our dot function, and it's an infix operator with a left and a right. So it's another one of those 2 argument functions with that sort of notation. But the cool thing, if you haven't spent too much time in the docs, is there is this little link up in the upper right of any function in the docs that takes you right to the Elixir source code, which is awesome. And so I was like, well, I read this, and it kind of made sense, but I wanted to know how this works. So let's see if this goes any deeper. We're going to click this and check out the actual Elixir source code for this dot function. So this is it. I looked it up, and this is the function, it's a macro in this case, and it's that single line. I was like, this is doing nothing. It leads to an error. What in the world is going on? So well, let's check out the errors. At least maybe that'll tell us something. Followed the arrow, and that led to a private macro in here, which returns Erlang error. And you see the message here. Elixir's special forms are expanded by the compiler and must not be invoked directly. So that's kind of a scary warning. This is where I realized, I touched the metal. This is like the creation of David. I feel like Jose's up there, and I just found the connection. This is where the compiler does the magic. I found the portal that leads to the part of Elixir that's not written in Elixir. So this was pretty exciting, but also a little bit okay, let's step back and look at the code that we were looking at before. So we got our dot function, and let's see what we can do with it down here. The 2 arguments, we have the empty list for the metadata. And the 2 arguments, we see the puts at the end, which is we know that's our function name. And then we have kind of this other mess of a 3-element tuple leading with the aliases. And there you go, 3 elements. Cool. So we know how to break this down. So we're going to pull it up, and then we have our function name at the beginning, aliases. And this applies to every module name. And it's basically a way to, when you're aliasing your modules with different names, this is how it kind of breaks it down. We're not going to go too deep into it right now, but you can kind of see, okay, the metadata is alias is false. We don't have an alias in this situation. So really, this whole thing just breaks down to becoming the module name. So just to simplify the other code that we're looking at. So it's this code determines there is no aliases. Boom, just use the module name. So to simplify this, while we're trying to understand it, we're just going to plug in our module name of IO. And then now we can see, okay, so we've got the dot function, special forms dot function, or macro in this case, and then we have our 2 arguments, the IO and the puts. So because we saw in the documentation that this period function is an infix operator, we can go ahead and put it down here in the center, and then we know that the first argument for an infix operator goes on the left, and the second one goes on the right. And the cool thing about infix operators is spacing actually doesn't matter. As far as I could tell, spacing between the arguments on the left and right does not seem to matter. So in this case, we can just put it together, And now there it is. That's how our normal module.function works. It actually calls this dot macro that does magic behind the scenes to be able to do the remote call to that module to get your function. And so that's it. That's our simple breakdown of our io.puts hello, because now we say, okay, so that first element is io.puts, which is our function, and then it's going to call the hello argument. So piece of cake. Now we're going to look at def macro, and we're finally, oh my goodness, like 25 minutes in, we're finally going to define a macro. So let's check this out. First, we'll put it in a module, just like functions that go in a module. We'll just call it my macros. Then we'll define the macro, and just like it's really similar to how functions are defined, we just use def macro instead of def. And then we're going to go ahead and make our own version of the general if statement. So we're going to call it my if, and then we need to add some arguments here. So the thing about a macro that makes it different than a function is these arguments are actually like converted to a quoted expression format when they're brought into here. So like right here, this condition, if the condition is 1 plus 2 is equal to 3, it doesn't convert to true. So like if I use the condition later in here, it isn't true because it converts it to that quoted expression. So like if we go back to IEX and check it out, like quote do 1 plus 2 is equal to 3, we get this 3-element tuple with another nested tuple. And this is actually what's going to be that argument in the macro. So condition becomes the AST version. And then over here we have the do and the else clauses. And do and else are a keyword list, which is a tuple inside of a list. And so those actually will be the same, but the clauses inside will also be converted to the quoted expression version. Everything in here will be quoted, turned to that quoted expression, but the do and the else will stay the same because they're quote literals. But anyway, so we're going to go ahead and implement that. And we're just going to use case. So we'll do case condition. If it's true, use the do clause. Otherwise, use the else clause. But because we're doing a macro, not only does it convert, automatically quote all of our arguments, it also requires that we return a quoted expression. So the return value in this can't be the do clause. It has to be like a quoted version of the do clause because it's expecting an AST to be returned. So you'll see this in most macros, except for more advanced ones might do some more complicated stuff. But in general, you define a macro, and then pretty much the next line is you do quote do. And that's going to mean any code that I write in here is going to be converted to that quoted format before it's returned, which is what we want. So we're going to put the quote do right there, wrap it around our case. But now we have the problem of condition is now going to be converted to just a variable, and we want it to convert to our argument. So that's where unquote comes in. So now that we're inside of a quoted expression, any arguments or variables we're putting into here need to use unquote. So we unquote the condition, and we do the same with both of our clauses. So we unquote both of those. And there we go. This is ready to go. We're going to go ahead and jump to IEX real quick and check this out. So first off, we need to require my macros so that we can use it. And then we're going to do the if statement we've been using the whole time, but now we're going to use our macro version of it. So my macros dot my if 1 plus 2 is equal to 3, do this, else that. And boom, gives us this. So let's try it again. We'll say 1 plus 2 is equal to 10, which is clearly not true, and it returns that. Perfect. So this is real simple. But you might be looking at this and thinking, well, can't I just do that with a function? Why is this different than a function? Why don't we just get rid of def macro, the quote, the unquote, all that? We'll just make this a function and try that out. So we'll jump back to IEX and we'll do that. So we require my functions. We do the same thing with my else, 1 plus 2 is equal to 3, and it returns this, and it returns that. And you're right, it worked exactly the same. Why do we need macros? So the reason we need macros is the function version is actually like executing the arguments before it gets through the function. So to show that off, instead of returning just this, we're going to say if 1 plus 2 is equal to 3, puts this, print out this. Otherwise, print out that. So this is our function version, and we're going to go ahead and try this out, and it prints both. Well, that's not very helpful. Like we don't even know if the condition was true or not because it printed both. Well, what if it's 1 plus 2 is equal to 10, and does the same thing. No matter what happens, it's going to run that function. But the macro version does not run the function until it gets executed at the end. So we'll run the macro one, we do the same thing, we put the io.puts this and io.puts that, and we get what we wanted. It's only printing this, and the reason it can do that is because io.puts that is in the quoted expression format. It doesn't need to run until the macro ends, and because the macro, the case doesn't happen for that, it never runs, which is great. So that's like one thing that macros give us there. We're going to do one more real quick example. I know lunch is coming up, so we're going to wrap up real quick. But one of the things that I love about Elixir that really made me fall in love with it is pattern matching. And one of the super cool things that you can do with macros is you can pattern match on that AST format, which lets you do some really cool, really powerful things. So instead of doing something really powerful, we're going to do something really simple and silly, but just to show off the pattern matching. So this shows, like, this is a simple macro that is just taking in a normal function with 2 arguments. And so we're going to use that format, and we're going to actually pattern match on it. So we're going to take, this is going to accept a simple addition problem, and then it's going to print it out kind of in that stacked, like, elementary school style. So we can see in our terminal, like, 1 plus 2 with the line, and then the answer. Really, it's really useful here. This is like the beta version, so all we do is plus. If you're trying to subtract something, you got to go elsewhere. And because this is so we defined the left and the right, which is because it's an infix operator that's coming in. So when you run this function, we're running my_macros.prettymath 1 plus 2, and then it's going to print this out. So we'll take the left to right, plug those in there, and then we capture that entire AST and return that at the bottom, because that will then run that code to give us the actual answer at the end. So we're going to go ahead and run this in IEX real quick. First, we require our macros. There we go. And then we're going to run my macros.prettymath 1 plus 2. And boom, yay, it worked. It used the pattern matching. It was able to pull the stuff out of the AST and throw it in here, which normally you can't do because, like, in a function, that argument's going to be, like, evaluated, and so your argument is just going to be 3. You're not going to get the 1, you're not going to get the plus, you're not going to get the 2. But with macros, you can pull those little pieces out and do stuff probably a little better than this. This has a few issues. If you add 2 things together that are 10 or more, it's not going to line up. But my product manager says it's good enough, so we're going to go ahead and ship it. And that's it. My name's Jesse Anderson. You can follow me at Jesse J. Anderson. I created kind of a list of some different useful resources. You can go to bit.ly/elixir_macros. And just a few plugs for if you're interested in learning more about macros, there's the book by Chris McCord, Metaprogramming Elixir, that's really great. That was super helpful for me and kind of gave me, like, there's a lot of aha moments for me when I was reading that. There's also a great blog series by Sasha Urich. It's like a 6-part series called Understanding Elixir Macros, and that goes really deep. It's super good, and that's just free. So sorry, Chris. You guys should do that free one first, and then afterwards maybe check out Chris's book. And there's a few other videos that I linked, so yeah, check that out if you want to know more. And that's it. I'm not going to do any questions because it's lunchtime. So thanks.